our brain, the psyche, but at the same time, some amount of testosterone will give the message to the pituitary also. This is again a negative feedback, okay? So now you are considering the LH loop, GnRH to LH to testosterone, and testosterone is going back to the pituitary itself. It is not producing anything else. It is going by itself back, and it will exert the feedback effect on the pituitary and a little effect on the hypothalamus as well, okay? So this is the way how you have the two loops operating. One loop is the FSH loop and the other loop is the LH loop. Are we done with that? No problem? Okay? All right. Read it yourself. Whatever we have discussed, it's maktub in the slides. We don't have to read from the slides. Well, yes. Look at the secondary sexual characteristics. Keep in mind, have a distinction between the primary and the secondary sexual characteristics. First of all, I'd like you to tell me, what do you mean by primary sexual characteristics? Yes, dear? Let's listen to him. Yeah. Okay. Well, the hallmark of the primary sexual characteristic is the testis actually, okay, along with the presence of the genital system, other parts of the genital system, with internal genitalia and the external genitalia, okay. These are giving us, all of us as males, the primary sexual characteristics. The development of the internal genital tract and the external genital tract when all the normal hormones are there in the developmental process. This is, but the hallmark is the testis, the indicator is testis, okay, gonads basically. What do you now think about the secondary sexual characteristics? We have done that. Yeah. One more person, anyone else can? Yes, Abdullah, you can?
The characteristics that are found after puberty.
The characteristics that are found after puberty, and what are those characteristics which are found in the puberty?
Hair, body hair.
Body hair. What else? Okay. Hair distribution is a good word, okay. It's a secondary hair distribution now coming up, yeah. Muscularity, the changing in the muscular content of the body, okay, all right. Voice changes, okay, that's very good. What else? Okay, size of the external and internal genitalia. Now the proportional growth according to the need of the body, yeah.
Libido also.
Libido, okay. Well, yeah, that is the psychological drive or a desire towards opposite sex. And a male sexual orientation is developing. That's great. What else? Yes, dear?
Sex drive.
Sex drive, yeah, it is there, okay. That's so good. What else? Yeah. Well, actually we have gathered it, you are right, okay. The skeletal system develops a special contour along with the muscularity. So musculoskeletal system typically changes and turns a person into a male adult, okay. So we see it. What else? Anything else? Skin changes also, definitely. Skin changes, the pigmentation of the skin and thickness of skin, all those. So all these sets of characters which are visible and inside also, well, all these secondary sexual characteristics are there at the time of puberty and will take a couple of years to develop completely. Okay, these are secondary sexual characteristics. Well, we believe that it's a distribution between testosterone and dihydrotestosterone that will decide that secondary sexual characteristics develop normally. Some of the chunk will be taken by the testosterone, the other functions will be taken by dihydrotestosterone. They are same. They are same, one after another, two brothers actually. The bigger brother is testosterone and the younger brother who is transformed is the dihydrotestosterone, isn't it? Okay. All right. Okay. A quick run over the functions of the Sertoli cells because we cannot really forego the role of the Sertoli cells. One or two functions that we have already discussed for the Sertoli cells. I just want some other functions for the Sertoli cells because it's a multifaceted cell, beautiful functions really, okay. Unbelievable functions, a great support for the testis, without which it's unimaginable to have a normal environment and homeostasis of the testis. So one function, aromatase, you know that, formation of estrogen, khalas. One function is release of inhibin, which we have done, feedback function, okay. What else? It's forming a special barrier, okay, that we'll demonstrate also. One good function, blood testis barrier, okay. What else? What else? Any other function? Yes, dear? Spermiation, okay. All right, different steps. Nurturing the sperm, it's like a mother cell, okay, which is keeping the sperm, young sperm, the developing spermatogonium into spermatid and spermatid into mature sperm. All these stages are happening in the folds of the Sertoli cells. So Sertoli cells is supplying attachment and supplying the nutrition and hormonal support and all sorts of support to the growing sperms, the stages of sperms. So all the sperms develop in the folds of the, yes, that's a very, very important function for spermatogenesis. What else? Please keep mobiles in sight. Do not use or leave the class. That's the last time I'm saying it. Okay. Yeah. Anything else? Yes, dear.
It secretes androgen binding protein.
Oh yes, ABPs, androgen binding proteins, a very interesting issue, very good point. Androgen binding protein, a little protein secreted by the Sertoli cells, very clever cells, Sertoli cells. Sertoli cells, they know that if testosterone is coming into the cell, Sertoli cell, testosterone is a lipid soluble substance, isn't it? As it can come, it can also leave the cell. So Sertoli cell cannot do, Sertoli cell wants testosterone and it wants to trap and it wants to hold the testosterone as much as possible. So what does it do? It produces a special protein and that protein catches or binds the testosterone. So this protein becomes the mustada of the testosterone. So androgen binding proteins are the trapping proteins inside the Sertoli cells and they hold a good sufficient amount of the testosterone and then slowly releases it as it is needed by the Sertoli cells. A very good function, okay. Holding, why we say that there are very high concentrations of the testosterone in the region of the seminiferous tubules, inside the seminiferous tubules, because of this androgen binding protein. This protein is modued inside the cell and this protein is secreted outside the cell to hold the testosterone as much as possible. That a very important function. What else? There are some other functions as well, okay. A special substance called Mullerian inhibiting factor is also secreted during the embryogenesis and fetal development. That factor will cause the inhibition of the Mullerian duct system. What is Mullerian duct system, by the way? In the females, you know, we develop as a unisex creature. In the beginning, indifferent gonads are there. The male system and female system both are growing. Now somehow, if we are males, we have the Y chromosome, then the female system has to disappear. Now, you have to make it disappear by secreting some special substances or proteins. MIF is one of the proteins which is secreted in the fetal life, which causes the vanishing or disappearance of the or inhibition of the female system if the male is there, okay. So the Wolffian duct system will grow and the Mullerian duct system will become rudimentary, okay. So one more thing from the developing fetal testis is MIF, which is secreted. This MIF will cause inhibition of the growth of the female system, yani Mullerian system, and it will allow the Wolffian system to develop into the male genital tract completely, okay. So this is one more feature. So inhibins release of MIF and, okay, well, blood testis barrier is one very important function which was there. Let us have a look at the blood testis barrier. I'll show you a diagram, okay. Just have a look at the diagram here. Can you identify this is the seminiferous tubule, section of the seminiferous tubule here, okay, and this is the lumen here, this is the outside border, these are the germ cells, okay, which will differentiate into the different stages of the sperm development, and finally they will give the sperms, and these sperms which are formed here. So these cells are changing and finally changing and forming the sperms. When they grow mature, they leave the Sertoli cells. Look at the Sertoli cells. Do you see the Sertoli cells? This is the Sertoli cell, okay? This is another Sertoli cell, all right? This is the connection between the two Sertoli cells. This is the connection between the other Sertoli cell and this Sertoli cell. Here you have the connection between the two. It means Sertoli cells are very intelligently placed, okay? They are forming kind of a continuity or a barrier, okay? Now look at the first level of the cells. Do you see, are these cells lying inside or outside? Outside, okay? Look at this special contact of the Sertoli cells, okay? The first generation of cells, which are the principal cells, they will divide by mitosis and they will give the sperms. Later, by meiosis, they are lying outside. Now the problem is that these cells cannot, they are logged actually, they are logged, okay? They cannot move here and there. They are logged, they cannot move here, they cannot go up. So Sertoli cells are making sure that they keep the cells in custody or they keep it in locking. You come here. You come here. And see. Go forward. We are 3 Sertoli cells. Okay? 1, 2, and 3. Like this. We are holding. Now you are the spermatogonia or the germ cells, okay? If you want to go, can you go from here? Okay, especially these front cells, all right? So it means, and behind we have the generations of developing sperms, okay? So we are the guard, like Haris, we are holding it, okay? We are forming a barrier actually here, and this barrier is the blood testis barrier. Outside we have the blood vessels also موجود, outside the seminiferous tubules, and here we are forming a barrier. So the substances from the blood cannot enter because we are locking and holding our hands, okay? And at the same time, these cells without permission cannot leave. But we have to give relief to these cells also. After some time, what I will do and what we will do is, we'll leave the hands and we'll say, okay, khalas, now you can go and you can go. So I'll allow some of the cells to go and they will move and they will start working. And again what we'll do? We'll close the barrier again like this. So Sertoli cells open their barrier and close it time to time so as to release the developing cells, a generation of the cells, and again they hold their barrier like this. So they are performing a perfect mechanical function. This is the way the whole seminiferous tubules are lined. And look at the size of the cell. Cells are موجود from the periphery to the center. They are transluminal cells. The whole lumen of like this is covered by, can you see? From the lumen to the periphery. So they are transmural in the sense. The whole wall is covered by these cells, okay? So Sertoli cells are very dynamic cells. They form and they leave whenever it is wanted. Most of the time they hold it like this, function is like this. But sometime when they want cells to release, they will release it and quickly they will hold it again like this. Thank you very much, my dear Sertoli cells. Sit down, okay? All right. So you got the idea of the Sertoli cells, right? So they are doing mechanical functions, they are doing hormonal functions, they are doing so many beautiful things really. A great support. These are the functions of Sertoli cells. Now, I am not going into the process of spermatogenesis by mitosis and meiosis because that process has been done before also. But in general, we are producing sperms from one germ cell, primitive germ cell, okay, spermatogonium. We are producing 4 sperms. The spermatogonium is a diploid cell with 2N DNA. And finally, when we form 4 sperms from each cell as a final result, okay, haploid number, half that number. Haploid is the requirement because it has to fuse with the ovum again to become diploid as a normal cell, as you know that. Now, look at different stages very quickly, okay. First you have increase in number of the primitive cells by mitosis, and then they are released inside, and then they undergo the process of meiosis. Meiosis 1 and then meiosis 2. And as a result of meiosis 2, finally 4 mature sperms are formed from wahid spermatogonium. Okay, that's the ratio. 1:4 ratio is established there. In the oogenesis, if you remember, from 1, okay, you are forming only 1 ovum, because you are left with the polar bodies and you destroy the polar bodies. You only form 1 functional ovum. But here you are getting a better result. Okay, it's 1 giving rise to 4. Okay, so look at the number of sperms there also at the same time. Okay, all right. Just a nomenclature of the stages. After passing through the stages of meiosis, finally the sperms, they develop their tail, okay, and their formation of tail and shaping into a complete mature morphology. This process is called the spermiogenesis, okay, spermiogenesis, when you are transforming the spermatid into sperm in the final stage. Now these sperms still remain attached to the folds of the Sertoli cells, okay. They still need some time. They are inactive, they are still immature, they are not dynamic and motile. Now they are released finally into the lumen of the seminiferous tubules, and they will stay in the epididymis, okay. This process of release and keeping them there is called spermiation, okay. So you have done the spermatogenesis. The last step of spermatogenesis is spermiogenesis, and after spermiogenesis, once you are forming the sperm completely, now you will release that sperm into the lumen of the seminiferous tubules. Still it is inactive, still it is incapable, it cannot do anything good, okay. It is ready, but not ready for its final function. So spermiation, it remains there for a little time, for 24 to 48 hours or a little more time, stays there, and it fills the epididymis and even the vas deferens there, okay. Now the final change or the activity of the sperm will come when this sperm is actually released outside. It is ejaculated, and when it goes into the female genital tract, what will happen? It undergoes some changes, still some more morphological changes, and these final changes results in functional development, and you call this process as capacitation, okay. What do you call it? Capacitation. So capacitation is the process by which the sperm becomes eligible to enter into the ovum. Before that capacitation, it is mawjood, it is moving, but maybe it cannot penetrate, it cannot go inside, it cannot break that fort or the wall, okay. So after doing all these steps, okay, these are the stages. Just have a look and see it yourself how it is done in the histology and embryology. You are starting from an immature form of the spermatid, and spermatid is changing and finally transforming, rearranging the Golgi apparatus in the mitochondria, and it's completely forming the head, middle piece and the tail, and after that it will undergo spermiation, and after that it will go capacitation, and then it will perform its function. So step by step everything. Capacitation where? Spermiation where? Spermiogenesis where? Rest of the stages where they are happening. You have to keep yourself oriented at all levels actually, okay. All right, that's done. Total time 74 days, read it yourself. It's only a repetition of what you have done in the foundation module, okay. No need to do all this. Our main idea very quickly is to focus the functionality, okay. Spermatogenesis, now it's a very important process. It's an ongoing process right from the age of puberty, as we grow into the functional males, the capable males, up to the age as long as we are living. If there is no pathology, there is no problem. Spermatogenesis goes on. It declines after the age of 85, 90 years, I agree with that, okay. But maybe up to 60% of the normal or 50% of the normal, still sperms are there, and if the person is living for 150 years of age, he can still reproduce. Fertility is still there. It is a little less than what he had before 50 years of age, but still fertility is there. So spermatogenesis, an ongoing process, a wonderful process, and blessing of Allah really, controlled by so many factors. Look at the factors: hormones, okay, The temperature, okay, diet also to some extent, nutritional support, and some here and there other miscellaneous issues which you will see very quickly. Okay, very quick summary of the hormones. Now gather all the hormones which are needed directly or indirectly for the spermatogenesis. It's very easy. If I say, is LH required directly for the spermatogenesis? No. Acting on the sperms, and difficult to say really, because we don't really see the receptors of LH working directly on the sperms for that process. It may be there, but we believe that LH is coming and it is causing the release of the testosterone. It means Leydig cells. So the control will be indirect because testosterone is required for spermatogenesis. LH is controlling testosterone. So the action becomes indirect action. Okay. What do you think about FSH? Most likely it's the indirect action. So it's very easy. What do you think about testosterone? Almost all the stages, nurturing in all the stages, it is supported, very well supported by testosterone. And what do you think about the little estrogen which is being developed, which is made by the testosterone aromatization? It is the direct action. It is which stage specifically? Spermiogenesis. You have to be very clear about that. We know one stage, maybe others also. We know one stage for sure. For certain it is spermiogenesis. When the tail is developing in the last stage of formation of morphology, well, you need that estrogen. Okay, that's very, very important. Along with that, other hormones which are metabolically supportive, which is an understandable fact that without growth hormone, any cell, proper cell, cannot maintain its life and the function will be suppressed to some extent. Okay, so growth hormone deficiencies will also affect spermatogenesis. A background metabolism has to be supplied by some hormones. Major metabolic hormones of the body, growth hormone for the growth purpose. Okay, and besides that there is one more most important metabolic hormone, thyroid. In the thyroid deficiencies we have a problem of fertility changes. Not very much, but definitely the fertility has to be affected one way or the other because metabolism is affected, isn't it? And sperms are also the cells, they have metabolism, all the stages. So all those supportive hormones, they have their permissive role. They allow the normal functions. If they are modude, growth hormone, thyroid hormone, other metabolic hormones, they will allow all the hormones on their background to act normally and they will have a full-fledged spermatogenesis. Okay? So consider all the hormones as logical. Yeah. Another very, very important point, temperature and testes. Do we ever wonder why has the nature given us testes which are hanging outside? Okay, even though they are so precious for their functions, yet they are exposed to the external insults and they are vulnerable. They are not kept inside the abdomen. Had they been kept inside, they would have been more protected. Okay, but they are hanging outside. What is the philosophy of the testicles in mammals outside? Most of the mammals, very few mammals are exceptions who have their testes intra-abdominally. Okay, but other mammals, almost all mammals, they have the testes outside. Okay, now what is the idea? Temperature. Testes are temperature sensitive organs. Spermatogenesis requires a special temperature which should be less than our internal body temperature or the core temperature. Our core temperature is 37, we all know that, taqriban, isn't it? No way. Testis cannot bear that temperature for a long time. For spermatogenesis to happen, no way. Okay, it means you have to drop the temperature to around 32 or 33 degree or so, like this. From 31 to 33 degree is a better temperature for normal spermatogenesis to occur. Okay, but fortunately we all know as an experience that there is a very specific movement of the testis towards the abdomen or away from the abdomen by some special supports or by some special muscles. Can you name those muscles, my dear boys? Dartos muscle, where is that present? In the scrotum. That's scrotum muscle. Viewing the scrotum, observing the scrotum, scrotum is a moving structure because of the muscle, isn't it? It keeps on changing the shape because of that muscle, Is it a skeletal muscle, by the way? No. It's a smooth muscle, and there are waves coming in that, and these waves are changing the shape depending upon the external temperature and the requirement of the testicular temperature. Well, the shape of the testis is changing. Sometimes it is coming closer to the abdomen because of this contraction of the muscle, and relaxation will bring the dangling of the testis or hanging of the testis as low as possible. This is one thing. What is the second muscle that is also holding the testis, please? Scrotum is the sac. Yeah, cremaster muscle in the spermatic cords, okay? Contraction, is that a skeletal muscle or a smooth muscle, by the way? Smooth or skeletal? Come on, quickly. Smooth. Sure? Skeletal. Not attached to skeleton. Not all skeletal muscles are attached to skeleton. This is one fact. Is it under your control? Is it under our control? No. If we want to contract that muscle, can we contract? So, skeletal muscles, some of the skeletal muscles are like you have no control. They are not voluntary, all the muscles, please. Okay? Apart from the fact that skeletal muscles are voluntary and they are controllable, not all of them. Exceptions prove the rule. Inside your ear, you have small muscles, tensor tympani and stapedius. Do you have that? Small muscles inside the ear, very small muscles. Okay? You are not done with the special senses. Very small muscles. Can you contract the small muscles of the ear? No, we cannot. So these are the examples where you have no control over them. One of the examples is cremaster also. Okay? Anyway, testes are very sensitive to temperature. So temperature has to be kept according to the optimal conditions. Okay? In cold weathers, what is our experience? What happens to the testes? Are they moving close to the abdomen or away from the abdomen? They want a warmth of the abdomen, so automatically the scrotal size changes and they come closer. What happens in shadid hot weather, hard conditions? Definitely it's changing, okay? They become loose and suspended down, isn't it? Okay? It is according to the temperature adjustment. All right? Spermatogenesis is affected by changes in the temperature, and we have to be very careful about these changes as doctors, as medical students, and as males. You should know what are the requirements. Wearing very tight clothing or tight underwears, okay, one factor. Many people are in habit of using extra small or tight underwears. Okay, what is the disadvantage? Again, you are keeping the testes as close as possible to the abdomen and more vulnerable to temperature. If you are in habit of doing it for years and years and years, then you are affecting your process of spermatogenesis, and it can turn into a state of subfertility sometimes. One factor. Second factor, wearing the garments or underwears like athletes. Have you seen the athletes? They wear kind of special materials which are waterproof and airproof totally. Okay? Now the synthetic materials are so well developed, they are so tight fitting, and they are so that air cannot pass through that. And again, they retain the temperature. So again, wearing those clothings for a very long time, of the day and durations, again, it's a problem. Two factors. Those persons who, some of us, all over the world, we are in habit of having warm baths, sauna bath, jacuzzi, and all those steam baths, okay? And many persons, their cultures all over the world, they keep half of the day inside the water and they feel very comfortable, they're soothing. But at the same time, what is the disadvantage of that? The spermatogenesis slows down, okay? All these procedures can slow down the spermatogenesis, so we have to keep in account all those factors which can modify the temperature around the testis. So please Whenever you are advising someone or when you are considering yourself or others, you have to keep all these facts in mind. Okay? Yeah.
Is it reversible or irreversible?
It is reversible to a major extent, but if it goes very long, sometimes there are degenerations happening in the seminiferous tubules, and those tubules will not come back. Okay? Initially the process is reversible, but if it is carried for a very long time chronically, then there is no guarantee about the process. Okay? Alright, so cooling mechanisms are there. You know that in the diet we need a plentiful amount of vitamins and the proteins which are required for the synthesis of